Hi there. Today we're going to talk about proving triangles congruent. Now, you're aware from a previous section that it is possible to prove two triangles congruent if you know that all sides and all angles of the two triangles are congruent. But in fact, you don't have to have that much information. And that's what we want to talk about today. There are actually 5 different ways that you can prove triangles congruent. And we're going to talk about 2 of them today. One is called SSS, for side, side, side. And the other one is called SAS, which stands for side, angle, side. Now, first of all, let me explain what that means. If we look over here, I've drawn a couple of triangles up here. If we know that this side is congruent to this side is congruent to this side, and this side is congruent to this side, then you have all 3 sides of one triangle congruent to all 3 sides of the other triangle. And that is enough to establish that the 2 triangles are congruent, and that would be by SSS, side, side, side. We can then say triangle DOG is congruent to triangle CAT. Now, notice that this statement tells you a lot about the triangle congruences. Side DO over here is congruent to side CA over here. Side OG over here, the bottom here, is congruent to side AT, the bottom here. And finally, side DG is congruent to side CT. That's DG to CT. So it has to be written in such a way that the sides and the angles match up accordingly. I could have written DGO is congruent to CTA, but I have to make sure that I do them both in the same order. All right, that is side, side, side. The other one we're going to talk about today is side, angle, side. So let's take these 2 triangles. If we have a side here congruent to a side here, we have an angle here congruent to an angle here, and we have a side here congruent to a side here. That gives us side, angle, side to side, angle, side. So this is SAS, and notice that the angle is between the 2 sides. The congruent angle is in between the 2 congruent sides. Here, between the 2 congruent sides. In other words, this would not be the same. If I had an angle up here and then a side and then a side, that's not the same. The angle must be between the 2 congruent sides. And in this case then, I could say triangle COW is congruent to triangle RAT. Okay? Or I could have said CWO is congruent to RTA, or ART is congruent to OCW, but again, I have to have them in the same order so that the sides and the angles match up. All right, side, 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 and side, angle, side. Now let's take a look at a proof. I'm going to erase these and look over here to our right, to your right. And here we have a triangle, a large triangle, but it's been divided down the center so that we have actually 2 smaller triangles inside. Our goal is to prove triangle DRA, that would be this triangle, the small one over here, is congruent to triangle DRG, that would be this smaller one over here. We are given 2 pieces of information. DR is perpendicular to AG, and RA is congruent to RG. So I will mark RA congruent to RG. Now, the perpendicular part is going to give us an angle, because if two lines are perpendicular, then they intersect to form 4 right angles. You may recall that from a previous chapter. So let's start out over here with our given information. We have statements and we have reasons. Number 1, we have given DR is perpendicular to AG and RA, here, let's mark those correctly, RA is congruent to RG. And that is given. Number two, since we have these two perpendicular, that allows us to state that DRA and DRG are right angles. You could also do this by, well, let's do it this way. Angle DRA and angle DRG are right angles. And that is definition of perpendicular. Actually, let me think about that for a moment. Two lines are perpendicular, then they form four right angles. We could actually do it either way. The theorem says if two lines are perpendicular, then they intersect to form four right angles. So we actually have a choice here, I think. I'll leave it like that. All right. Number three, we can then say, because all right angles are congruent, we can say angle DRA is congruent to angle DRG. All right angles are congruent. All right. Now we have, I'll put this here and I'll put this here. We have a side and we have an angle congruent to a side and an angle. We need something more. And that something more is going to be the shared side DR, because you will notice that DR is a part of this triangle and a part of this triangle. So let's start out then by saying, let's put here, DR is congruent to DR. And the reason is the reflexive property. And we have to do that because we have to establish that the DR of this triangle is the same as the DR of this triangle. Now, if you look over here, what we have originally, up here, we had a side. So I'm going to mark that with an S. Down here, we have an angle, and here we have a side. And if you'll notice, the angle is right between the two sides. So therefore, in order to prove these two triangles, congruent triangle DRA, congruent to triangle DRG, the reason is going to be side, angle, side. Because, again, here, I'm going to mark this. We have a side, an angle, and a side, congruent to a side, an angle, and a side. One thing I want you to notice about this is that you were not directly given all the necessary information. We had to determine it, first of all, like this, but more importantly, there was no mention anywhere of side DR. We had to figure out that that was the third side of the two triangles and then establish that it was congruent to itself. And that's going to be fairly typical in these problems where you have to ferret out or find the information that you need in order to prove the two triangles congruent. And I believe that concludes our discussion of section 4.3. The next video will be on section 4.4, which is two additional ways of proving triangles congruent. Thank you.